Welcome learners. In our lesson today we look at the topic of energy changes in physical and chemical processes. Now we'll look at the subtopic of enthalpies through experiments, which include molar heat of solution, molar displacement, molar heat of neutralization, and molar heat of combustion. Now, what the student is required to know in these three enthalpy through experiments is the definition, how to find molar heat, how to find change in temperature, writing thermochemical equation, drawing energy level diagram, then source of errors. So we begin the first one, molar heat of solution. Definition is the enthalpy change that occurs when 1 mole of a substance is dissolved in a solvent to give an infinite dilute solution. Examples include dissolving a given mass of sodium hydroxide or ammonium nitrate in water. 2. Dissolving a given volume of concentrated sulfuric acid in a solvent, e.g. water. Now first we look at how to find molar heat of solution. Steps to be followed. Step 1. Determine the heat change, that is delta H. Heat change is given by mass of solution times specific heat capacity times temperature change. Mass of solution is obtained by density of water times the volume of water used. Specific capacity is a constant which is given by 4.2 joules per gram per Kelvin or kilojoules per kilogram per Kelvin. Change in T is obtained by final temperature minus initial temperature. Note that a change of 1 degree is equal to a change of 1 Kelvin. Now step 2 is finding the number of moles, which is obtained by mass in grams over the molar mass. Then the last step, finding molar heat of solution. You take the moles in step 2 is the same as enthalpy change in step 1, or about 1 mole. Now the unit here is kilojoule per mole. The sign can either be positive or negative. It is positive when there is a temperature drop. It is negative when there is a temperature rise. Example, when 2.5 grams of ammonium nitrate is dissolved in 100 centimeters cubed of water, temperature dropped by 2 degrees Celsius. Calculate the molar heat of solution of ammonium nitrate. Bracket, N is 14, H equals to 1, O 16, density of water 1 gram per centimeter cubed, specific capacity 4.2 joules per gram per Kelvin. Solution, delta H is equals to MC change in T. Mass of solution is density of water times volume of water, which is given by 1 gram per centimeter cubed times 100 centimeters cubed. The answer becomes 100 grams. So we leave our answer in 9 grams because the C is joules per gram per Kelvin. Now delta H therefore is given by 100 grams times 4.2 joules per gram per Kelvin times 2 Kelvin over 1000. So the answer becomes 0.84 kilojoules. Number of moles is given by mass in grams of a molar mass. Molar mass is given by 14 plus 4 times 1 plus 14 plus 16 times 3 gives you 80 gram per mole. Therefore, number of moles will be 2.65 grams over 80 gram per mole, which gives you 0.033125 moles. Then the last step is 0.0 0.33125 moles is 0.84 kilojoules, or about 1 mole. Cross multiply, get 1 mole times 0.84 kilojoules divided by 0.033125 moles. The answer becomes plus 25.34 kilojoule per mole. It is positive because the temperature drops. Now, in other questions, you can be told to write a thermochemical equation. Now, this will mean you write a normal chemical equation and include the enthalpy change. In this case, you get ammonium nitrate solid, RO, ammonium nitrate aqueous, delta H plus 25.4 kilojoule per mole. Now, the energy level diagram for the above reaction will be learners. That in the lesson, the next lesson look at how to find change in temperature.